Hey, happy Friday afternoon, everybody. I just got done work and I thought I wanted to go out and quickly, while I had time, do a video on a topic that I've been really researching for a while. Those of you who know the channel know that my background is in science, engineering specifically, and one of the things that this just predispositions me towards is challenging and critiquing everything. And in the gardening space, there's a lot of hand-me-down, wives' tale, anecdotal information that really has no basis in science. Some things, like planting marigolds around your tomatoes, actually does have quite a bit of scientific backing to show the validity of. Other things, specifically two that I'm going to mention today, really don't. And these two things are actually core principles of permaculture. And permaculture doesn't hinge on these being true or not, but I've really had a hard time finding scientific-based research and evidence on chop and drop and nutrient accumulators. I'm going to challenge those today, and specifically for chop and drop with nitrogen fixation. Hey, obligatory pond clip for you guys who want to see the pond in every video. We'll get started in about 3, 2, 1. Now, if you're the type of person who just reads something, thinks it sounds good, and wants to practice it, keep doing it. It doesn't matter. If it's working for you, there could be other reasons why it's working. But at the same time, as a content producer and somebody who's giving out information, it's very important to me that I rigidly stay towards scientifically fact and proven information. Some of the things I've said over the years, I've realized actually may not have that much scientific evidence to support it. Let's start with nitrogen fixation. So here we are in the main food forest strip, and you can see that I kind of let things go a little bit wild. I let the comfrey and the rhubarb, do their natural life cycle, because it's been scientifically shown that when the plants are allowed to go through their entire life cycles, that they can make more robust and healthy root systems, which then lead to better production in the next year. One of the things that permaculturists teach is the rampant use of nitrogen-fixing plants to build soil. And when you start doing and digging a little bit of research, there's very little evidence that supports that a nitrogen fixer planted next to a peach is going to feed nitrogen nodules to the peach. Let's talk about how a nitrogen fixer works. Essentially, nitrogen fixers have evolved to be symbiotic with a bacteria that's in the ground. And this bacteria can actually use nitrogen from the air through the plant, and it can create these little clusters of nitrogen on the roots. These clusters of nitrogen then can be used by the plant to regrow if there's a nitrogen deficiency. Because of this reason, if there's not a lot of animal activity putting uric-based nitrogen down on the ground, these plants actually outcompete other plants. This is a sea buckthorn, and it is one of the permaculture staples of a nitrogen-fixing plant for a few reasons. One, it really responds well to coppicing and chopping. This is one of the core concepts of permaculture, chop and drop. Another reason, it actually has like miracle health food level berries that there actually is a lot of scientific research on. For more information on that, I have a dedicated video specifically on this plant. It's one of my favorite plants in the food forest. But it might be dubious whether or not it actually provides any nitrogen benefit to my peach. So one of the concepts espoused in a lot of permaculture is that we plant these nitrogen fixers in trios. We make a trio. So we make a pear tree, an apple tree, and then we put a nitrogen fixer in between them, and the nitrogen fixer will feed nitrogen to the other trees. And it's a great idea. It's just not really one that's backed in any science that I can find. Definitely, if you can find anything like that, post it in the comments below, because I'm very interested in this topic and I'd be interested to read it. But what a lot of people then say is that the nitrogen fixer might not actually just provide the nitrogen to the trees. And this is one thing that I've said before, that you have to actually physically cut the nitrogen fixer, because that will cause an imbalance of the above ground growth and the below ground growth. And when that happens, plants take energy from the roots, and it was thought that the roots will die back, disassociating those nitrogen nodules from the tree. This is one thing I've actually said on this channel myself a few times until I realized, maybe about a year ago, that I didn't have any scientific evidence for why I was saying it. I was only saying it because I'd heard other people say it. In this day and age, it's really important to question the things that you're reading, especially with all the media being controlled by like 6 corporations in the US, like 7 in the UK. People have political agendas to push on us when we receive this information. We see this a lot with stuff like climate change and politics. And no matter what you thought when I said that, if you thought that's the bad group, I'm on the good side, right? We have to understand that for both sides of any argument, there's a lot of misinformation spread at us from everywhere. Now, the gardening area is no different. There's a lot of people who make a lot of money running gardening blogs who don't actually really do much gardening. I've seen a lot of the big gardening channels on YouTube even. There's quite a few of them where if you see a satellite image of their house, they don't actually really garden, but they're an expert in gardening. I don't want to be that kind of person. I don't want to tell people what to do, and it's based off of something I maybe heard from somebody who doesn't even garden. So I really want to be able to get the actual scientific facts out to people. And in this one area, cutting a plant, creating an imbalance of above ground and below ground growth, and then that plant shedding roots to actually disassociate the nitrogen nodules, that doesn't appear to be based in any kind of research. Now, what does happen is that the plants have to take energy from somewhere. They take it from the roots because it's the only thing they have. They have photosynthesis, and then they have mass. Those are the only 2 areas of energy that they can possibly draw from. And if they have no photosynthesis going on, they have to extract it back from their mass. And some plants are really good at doing this, specifically plants that have evolved being grazed by animals. If you're a piece of grass and you can't regrow after you've been eaten, you don't exist anymore because you've already died out billions of years ago. So many plants actually have evolved this ability to regrow above ground mass using the roots. But the dubious part is that they actually shed and break off the roots. And what I found actually over the past, year or so, and I'm certainly not a scientific expert in this fact, so double check everything I'm saying with your own research, and hopefully research of people who actually are, renowned experts in this field, such as Dr. Elaine Ingham. And what does she think on this? Well, she thinks that the roots don't actually die back. It's kind of like when somebody is heavy and they lose weight, like a human being, our fat cells don't actually disappear. They actually just shrink. And evidence is showing that plants do the same thing with their roots. They don't actually disassociate. They don't come apart. They actually just shrink. The mass and energy still gets used, but everything remains intact. So disassociating a nitrogen nodule by chopping it and dropping it doesn't necessarily work. Or does it? I think it might, but you have to do it in a certain way. So what's that? I can't help but just taking a little moment out of this and showing you my monarchs. What's that bin? That's a sacrificial bin. Okay, so what we do know is that when plants completely die, their roots get disassociated. Their roots, the entire root mass, actually ends up rotting and being returned back to the soil. So while a nitrogen fixing trio might not necessarily just automatically provide the nitrogen, if we can actually sacrifice the nitrogen fixer completely, then we can return all that nitrogen back into the soil. And secondly, fertility is not just about nitrogen. A lot of fertility is about the soil food web of life, and that really mainly runs on carbon. So if we're planting tons of plants and we're chopping and dropping them, and all we're getting out of it is carbon, we're actually still building soil fertility. And this is kind of what nitrogen fixation is all about. It's not focused on nitrogen, it's focused on building fertility. So just simply planting lots of plants and having them go through their natural life cycle, those plants are all putting root exudates down into the soil. That's all carbon, it's also nitrogen. And part of the fats and proteins that get put out, very heavy in nitrogen as well, actually. So as much as a nitrogen fixer, if it's just sitting in your food forest, might not necessarily be feeding the other plants, it's also supplying its own nitrogen needs from the air. That alone is going to reduce the nitrogen demands in the soil. It's also putting carbon root exudates into the ground. That alone is building soil life and fertility. So even though I do think that the nitrogen fixing chop and drop, when it's not done in a fully sacrificial manner, might be a little bit dubious, I think that it actually still has merit in terms of building fertility into your food forest, simply for the fact that it can provide its own nitrogen needs from the air. So for a gardener like Miracle Farm's Stéphane Sabkowiak in Quebec, who plants in his trios, I actually think he does get a lot of benefit out of those trios, simply because 1 out of every 3 of his trees are a carbon factory putting carbon into the ground, but are not taking any nitrogen out of the ground, or maybe not as much nitrogen because of the symbiotic relationship with the rhizobacteria that's taking nitrogen from the air. So if you did really want to build nitrogen into the soil with a nitrogen fixer, I think the best way you can do it is actually one of 2 ways. A full sacrificial, where you actually take that sea buckthorn, you let it grow for a while, and you kill it. You cut it right to the ground, and every time it regrows, you cut it again. Ideally, you're taking cuttings so that you can propagate them and replant them in kind of like this cycle where you're letting a nitrogen fixer grow, and then you're actually completely sacrificing it to cause the full root dieback and the return of that nitrogen to the soil. The other way we can do that is actually with just the natural process of an annual or a biannual dying just on its natural course. So for example, this is one of the reasons why you might have noticed I've really been adding a lot of lupin into my food forest. Each individual plant will actually go through its life cycle. It will grow, it will create nitrogen nodules in the roots, and then it will fully die as part of its natural life cycle without me having to chop and drop it. And when those roots from the dead plant die back, I at least postulate that that will then return the nitrogen back to the trees. And that might create a self-regulating cycle where if the nitrogen in my soil is low, the natural seed bank of something like a lupin will grow really well because that's the environment, that's the niche that it's outcompeted other plants historically in. That's where it does well. So they will germinate and they will actually take over, and then they'll return that nitrogen to the soil, and we might not get another flush of lupins for another couple of years, who knows. But that's probably because the nitrogen's actually okay in the soil, and they know that they can't outcompete other plants, so they may not germinate. But I still will have that native seed bank in my soil. That's my thoughts. I've seen a lot of that kind of thing pop up in people, permaculturists like Sepp Holzer. And he basically just sows out a ton of plants and he develops his seed bank. He doesn't create a food forest, he creates a seed bank on his property and then he lets it evolve over the years. That's kind of where I'm going with these biannual nitrogen fixers. So that's my thought on nitrogen fixers. Keep in mind, I'm not a scientist in this specific aspect. I just really like this stuff and I just do a lot of reading on people who are. But when I do read something and I realize that I've been parroting something for a while that has no scientific merit and backing behind it, and I look for that backing and I can't find it, you know, that kind of gets my Scooby sense up. And I think it's my due diligence to respond back to you guys about, you know, why it might work, you know, why it might not work, why it might not matter, and things that you can do in your food forest that will take advantage of all this information. So I think if you can transition your nitrogen fixers towards either full sacrificial, chop and drop and kill the plant, or you can turn it into a natural life cycle of a plant where the roots will actually die, so you get that full sacrifice, but it's done naturally. I think, theoretically, I think that makes a lot of sense to me, and it could help explain why some people do actually see results planting nitrogen fixers, even if the actual result isn't based on the actual nitrogen fixation. Okay, so one other aspect I want to talk about, and this is going to be at the end of the video, is going to be on dynamic accumulators and deep tap-rooted nutrient accumulators. There ain't a whole lot of science on this one either, and let's talk about that. Alright, it's a little bit ugly now because it's going through the end of its life cycle, and like I said, I let that happen. But we're talking about stuff like comfrey here. Now comfrey, the idea is, and a lot of permaculturists love this plant, because we just parrot the same information back. Comfrey's got a super deep taproot, and it does. I've dug it up before. This stuff is super thick at like 5 feet down into the ground, and there's been research that shows that it can go almost 50 to 100 feet into the ground. That is scientifically relevant. But maybe what isn't is the fact that it actually dredges nutrients from below and brings it up. And the conclusion is actually going to be that I don't really think it matters. And I know I'm showing my peach, but I'm really trying to show this butterfly. But I don't think it really matters. And the reason why that I say that is that, yes, most of the deep taproot of the comfrey is in the taproot. There's not a lot of laterals down there. And if you've dug up comfrey, you know that most of the laterals are actually on the surface level. And those laterals are the feeding roots. So the comfrey, the deep taproot, that's a stabilization thing. And the comfrey actually doesn't, or generally most plants don't actually get a lot of nutrients from the taproot. In fact, almost none. That taproot is literally just meant to stabilize the plant. But permaculturists will come, and I'm one of them. I've said it before. You chop it, you drop it, you build soil with it. And that soil comes from deep down in the ground, where it was sinking down towards the center of the earth. And I thought, why am I saying that? And the reason I'm saying it is I've heard other people say it. When I went to go and try and find some information on this, it's been a year now. I haven't been able to find any that supports this. But I also don't think it matters. And let's talk about why. Now, all plants basically grow and use photosynthesis, and they combine the sun's energy with water and nutrients in the ground given to them by the microbiology in the ground. And they return that, and they build their bodies, and they put more nutrients back into the ground to help attract more microbiology, to help grow more leaves, to help get more photosynthesis. And it's this snowball, which is the entire reason that photosynthesis is the biggest driver of the reason why there is life on the planet Earth. It's the regenerative thing that makes it so that the Earth can actually survive and rebuild itself. So I'm not saying that the comfrey plant or the dandelion or the dock isn't necessarily getting a ton of nutrients from deep down below. It kind of theoretically makes sense. A lot of what we understand about plants, which actually, in fairness, is very, very little, doesn't seem to support the fact that the taproot would bring nutrients up. But at the same time, I don't really think it matters, because even if the side lateral roots are where 99% of the nutrients in the comfrey come from, and that goes into the roots, into the leaves, only a very small portion of that does actually go into the leaves. The rest goes into the ground to help support the microbiology. Here's a good example of a comfrey plant that's going through its natural life cycle. It grows up, it makes a big tall bush, and then it kind of makes flowers, and it spends so much energy, making all these flowers and then later seeds, that it takes it out of all of this stuff. And this is just the natural life cycle. The plant's using all this to make its genetics. Once it does, it kind of gets lanky and the strength gets lost, the plant falls over, and what happens next? We get more leaf growth. So this is a natural cycle that happens with all plants. Comfrey will actually put on several flushes of growth like this. And even if these nutrients that are going in the leaves are coming from, say, the top 4 to 6 inches of topsoil, when they return back to the ground, they're actually returning back to the soil. And the delta on why we can have more energy going into the system, why it's not just nutrients are spent and the nutrients are recovered, is the photosynthesis energy. Because as the plant is doing photosynthesis, it's putting those root exudates into the ground, and that actually swells the microbiology under the ground. And it's that swelling of microbiology that now there's more bacteria and fungus to actually break apart the rock minerals in the soil to release those and chelate them for the plants. So as long as we can keep as many plants possible doing photosynthesis, we're getting constant energy into our system from the sun. So does chopping and dropping a deep tap-rooted nutrient accumulator and all those wonderful permaculture words, does that actually do anything? Yes, it does. But does it do it because of the deep taproot and dredging up nutrients from deep down below? Maybe not. We don't really know. I would say probably not, because a lot of the nutrients don't come from the deep taproot. But does it matter? If we're constantly chopping and dropping a plant, or this is just as equal if we let the plant do its natural cycle and we don't cut that off and then put it at the end of our driveway where we're taking those nutrients and we're putting them in the green bin, then we're actually returning all that nutrient back to the soil. And in this way, nature doesn't really do waste. So there's no waste in this system. If we can allow that plant to put its energy back into the ground, into the soil, we will build soil. We absolutely will, just simply because of the sun. So somebody who's practicing chop and drop of comfrey and they're constantly putting new comfrey down, what they're actually doing, even though they're maybe not, dredging nutrients up from deep below, what they're actually doing is they're keeping the plant in the most vegetative, fast-growing state as possible. And in this fast vegetative growing state, the plant is growing as many leaves as possible. And when the plant's growing as many leaves as possible, it's doing as much photosynthesis as possible. And in this way, you're cycling nutrients as fast as possible. So is the reason for the soil building the deep tap-rooted nutrient accumulator? Yeah, I don't know. And I don't think there's a lot of research that points that out. But is the practice of using those plants as a chop and drop soil builder a good thing to do? I do think it is. And anecdotally, and it's just anecdotal evidence, I feel like my systems where I have chop and drop and I drop the comfrey, that those really do respond with vigorous growth and most importantly, a lot of disease resistance. And I think it's because the plants have everything they need to build thick, healthy cellulose walls that prevents disease and pests from attacking the plant. So thanks for watching. I hope this is a refreshing video, and if it challenges some of the things that we've heard, especially in the permaculture space, that just gets parroted and repeated, I think that's a really good thing. And I think that it's important that if we hear things even from myself, you challenge me on it and say, hey, I don't know if there's any scientific research to back this up. And I think that's important that we do that with everything that we read, not just about gardening, with everything. When someone's telling you something, challenge their background and their qualifications for telling you that thing. Everything you heard in this video is coming from a mechanical engineer, and I'm talking about plants. So challenge that. I don't know what I'm talking about plants. I'm only learning what I'm reading from the actual experts. So go out and read what the actual experts are saying. Thanks for watching, everybody. I'll see you on the next one.